In this tutorial, we will perform the analysis on an assembly of two parts in Abaqus, comprising a cube with a hole and a cylinder.
After creating the two parts, we will navigate to the property module to define the material. We will be using steel in this tutorial. Next, we will create a steel section. Afterward, we will assign the steel section to the two parts we have created. After assigning the material to the two parts, we will now assemble these two parts in the assembly module. In our case, we will use the translation function to move the cylinder into the hole of the cube. To do this, we will select the cylinder and define a start point and an end point. Next, we will proceed to the step module and define our analysis step. We will conduct a general static analysis. Then, we will mesh the two parts in the mesh module. In this tutorial, we will explore how to achieve a regular mesh without needing to partition the parts. We will use the medial axis algorithm to generate the mesh. This algorithm is highly effective with cylindrical parts or parts containing holes. Next, we will use the local seed edges function to specify the number of elements to have on specific edges. We will now mesh the cylinder using the medial axis algorithm. After completing the meshing of both parts, we will click on Assembly in the Mesh module, and then calculate the total number of nodes of the assembly using the query function. Next, we will work in the Interaction module to define the types of contacts between the two parts. We will use the Find Contact Pairs function, which allows us to detect the surfaces that are in contact with each other. In our case, we have only two surfaces in contact, and we will define tie as the type of this contact. The tie contact constrains each of the nodes on the secondary surface to have the same displacement value as the point on the main surface that it contacts. To edit the tie contact, you need to click on the Constraint Manager function, which contains the list of tie contacts established. To apply the 100 Newton force, as shown in the image, we will first create a reference point in Abaqus and link it to the circular surface of the cylinder. Then, we can apply the 100 Newton force to this point, and the force will be distributed over the entire surface. We begin by creating this reference point, placing it at the center of the circular surface. Next, using the Create Constraint function, we will link the reference point to the surface by choosing the coupling option. Finally, we select the reference point followed by the surface and choose Structural Distributing for the coupling type. Next, we will navigate to the Load module to apply the 100 Newton force on the reference point and fix the surface of the cube. Then, we proceed to the Job module to create a job. After that, we select Submit in the Job Manager to initiate the analysis. Once the analysis is completed, we click on Results. We start by displaying the deformed shape by clicking on Plot Contours on Deformed Shape function. Next, we will use the Activate View Cut function to evaluate the constraints inside the assembly. We can customize the Cut function by clicking on View Cut Manager. Next, we will use the Create Display Group function, allowing us to hide and display different parts. For instance, in this tutorial, we will hide the cube. This way, we can display the bending constraints within the cylinder. To display all hidden parts, we can click on the Replace All function.